Welcome to Civil Engineering Edge, your one-stop destination for mastering the world of civil engineering. This channel is dedicated to students, professionals, and engineering enthusiasts who want clear, practical, and future-focused knowledge. Here, we break down complex engineering concepts into easy-to-understand explanations, real-world applications, and classroom-style learning. From core civil engineering subjects to advanced construction technologies, smart infrastructure, and career guidance, Civil Engineering Edge helps you stay ahead in a rapidly evolving industry. If you are passionate about building the future, you are in the right place. Introduction. What if bridges could warn us before they crack? What if buildings could design themselves to survive earthquakes, floods, and climate change? And what if construction sites no longer relied only on human labor, but on intelligent machines working with precision and speed? Welcome to the future of civil engineering, a future that is already being built today. Civil engineering has always shaped human civilization, from ancient roads and aqueducts to modern skyscrapers and mega bridges. But today, the field is undergoing a technological revolution unlike anything we have seen before. Traditional methods are being replaced by smart systems, data-driven designs, and automated construction processes. Engineers are no longer just builders, they are innovators, technologists, and sustainability leaders. In this video, we will explore the latest advancements in civil engineering that are transforming how we plan, design, construct, and maintain infrastructure. From powerful 3D modeling tools and sustainable materials to smart infrastructure powered by IoT and robotics reshaping construction sites, these innovations are redefining the future of cities and nations. So whether you are a student, a practicing engineer, or simply curious about how the world around you is built, stay with us, because the future of infrastructure starts right now. Key advancements in civil engineering. Modern civil engineering is driven by 4 major advancements: digital design technologies, sustainable construction practices, smart infrastructure systems, and automation in construction. Advanced software tools now allow engineers to visualize and test structures before construction begins. Sustainability has become a core design principle, focusing on eco-friendly materials and energy efficiency. Smart infrastructure uses sensors and data to monitor structural health in real time. Meanwhile, automation and robotics are improving construction speed, safety, and accuracy. Together, these advancements are transforming civil engineering into a smarter, safer, and more sustainable profession. Modern technology in civil engineering, 3D modeling and simulation. One of the most powerful advancements in civil engineering is the use of 3D modeling and simulation technologies. Tools such as Building Information Modeling, or BIM, allow engineers to create detailed digital models of structures before they are built. These models are not just visual representations, they contain data about materials, loads, costs, timelines, and maintenance requirements. With 3D modeling, engineers can identify design errors, clashes, and weaknesses at an early stage, reducing costly mistakes during construction. Simulation tools help analyze how structures will behave under real-world conditions such as earthquakes, wind loads, traffic movement, and temperature variations. This results in safer and more efficient designs. Another major benefit is collaboration. Architects, engineers, contractors, and clients can work on the same digital platform, improving coordination and decision-making. Construction planning becomes more accurate, reducing delays and cost overruns. In the future, 3D modeling combined with artificial intelligence will allow predictive design, where structures automatically optimize themselves for safety, cost, and sustainability. This digital transformation is revolutionizing how infrastructure is imagined and delivered. Sustainable construction and materials, sustainability has become a central focus of modern civil engineering due to climate change, resource depletion, and environmental concerns. Today's engineers are designing structures that minimize environmental impact while maximizing durability and efficiency. One major advancement is the development of sustainable construction materials such as green concrete, recycled aggregates, fly ash, and geopolymer cement. These materials reduce carbon emissions and make use of industrial waste, significantly lowering the environmental footprint of construction projects. Energy-efficient building designs, rainwater harvesting systems, solar integration, and natural ventilation are now common features of modern infrastructure. Life cycle analysis helps engineers evaluate environmental impact from construction to demolition, ensuring long-term sustainability. Additionally, sustainable construction reduces operational costs and improves occupant comfort and health. Governments and international organizations are also encouraging green building certifications, making sustainability a professional responsibility for civil engineers. As cities grow rapidly, sustainable construction is no longer optional, it is essential. The future of civil engineering lies in building infrastructure that meets present needs without compromising the ability of future generations to thrive. Smart infrastructure, IoT in action. Smart infrastructure represents a revolutionary shift in how civil structures are monitored and maintained. Using the Internet of Things IoT, sensors are embedded in bridges, roads, buildings, and dams to collect real-time data on stress, vibration, temperature, and structural health. This data allows engineers to detect early signs of damage, corrosion, or fatigue before catastrophic failures occur. For example, smart bridges can monitor traffic loads and structural behavior continuously, improving safety and extending service life. In smart cities, IoT systems optimize traffic flow, reduce energy consumption, and enhance public safety. Roads can communicate traffic conditions, street lights adjust automatically based on usage, and water supply systems detect leaks instantly. The biggest advantage of smart infrastructure is predictive maintenance. Instead of waiting for failures, engineers can plan maintenance based on real-time performance data, reducing costs and downtime. As data analytics and artificial intelligence integrate with IoT, infrastructure will become more intelligent, resilient, and responsive. Smart infrastructure is not just technology, it is the foundation of future urban living. Automation and robotics in construction. Automation and robotics are transforming construction sites by improving speed, precision, and safety. Tasks that were once labor-intensive and risky are now being performed by machines with exceptional accuracy. Robotic systems are used for bricklaying, concrete pouring, welding, and even 3D printing of buildings. Construction drones assist in site surveying, progress monitoring, and safety inspections, reducing human exposure to hazardous environments. Automation also addresses labor shortages and improves project timelines. Machines can work continuously with consistent quality, reducing errors and material waste. Autonomous construction equipment enhances productivity while lowering operational costs. 3D printing technology enables rapid construction of housing units, especially in disaster-affected or remote areas. These structures are cost-effective, durable, and environmentally friendly. While human expertise remains essential, automation allows engineers to focus on design, planning, and innovation rather than manual labor. In the future, construction sites will be intelligent ecosystems where humans and machines collaborate to build faster, safer, and smarter infrastructure. Career opportunities for civil engineers. Civil engineering today offers more career opportunities than ever before. With rapid urbanization, smart city development, climate-resilient infrastructure, and digital construction technologies, the role of a civil engineer has expanded far beyond traditional site work. Engineers are now needed in planning, sustainability, data analysis, automation, and infrastructure management. Governments, private companies, and global organizations are actively seeking skilled civil engineers to design, build, and maintain modern infrastructure. Whether you choose employment, research, or entrepreneurship, civil engineering provides stable, high-impact, and future-proof career paths across the world. Emerging fields in civil engineering. The evolution of technology has given rise to several emerging fields in civil engineering, opening exciting new career paths. One of the fastest growing areas is smart infrastructure and structural health monitoring, where engineers use sensors, IoT, and AI to monitor bridges, buildings, and highways in real time. This field focuses on safety, predictive maintenance, and disaster prevention. Another major emerging field is sustainable and green construction engineering. Engineers work on low-carbon materials, net-zero buildings, energy-efficient designs, and climate-resilient infrastructure. With strict environmental regulations worldwide, sustainability specialists are in high demand. Construction automation and robotics is another rapidly expanding domain. Civil engineers now collaborate with robotics experts to implement automated machinery, 3D printing of structures, and drone-based site analysis. Urban and transportation planning for smart cities is also growing. Engineers design intelligent traffic systems, metro networks, electric vehicle infrastructure, and pedestrian-friendly urban spaces using data-driven approaches. Additionally, geotechnical earthquake engineering, coastal and flood engineering, and infrastructure data analytics are gaining importance due to climate change and extreme weather events. These emerging fields allow civil engineers to work at the intersection of technology, sustainability, and innovation, making the profession more dynamic, impactful, and globally relevant than ever before. Salaries and demand in civil engineering. Civil engineering remains one of the most stable and high-demand professions worldwide. The growing need for infrastructure development, rehabilitation of aging structures, and smart city projects has significantly increased demand for skilled civil engineers. In India, entry-level civil engineers typically earn between 3 to 6 lakh per annum, depending on skills and specialization. With experience and expertise in advanced fields like BIM, project management, or sustainability, salaries can rise to 10 to 20 lakhs per annum or more. Government sector roles offer job security, steady growth, and additional benefits. Internationally, civil engineers are highly sought after in countries like the USA, Canada, Australia, UAE, and Europe. Average annual salaries range from $70,000 to $120,000, with higher pay for specialized roles such as structural design, infrastructure consulting, and construction management. The demand is especially strong for engineers skilled in digital tools, smart infrastructure, sustainable design, and automation technologies. Employers increasingly value engineers who combine technical knowledge with software skills and project leadership. As infrastructure investment continues to grow globally, civil engineering offers long-term career security, competitive salaries, and opportunities to work on landmark projects that shape the future of societies. Startup ideas for civil engineers. Civil engineers today have tremendous opportunities to become entrepreneurs and startup founders. One promising startup idea is a BIM and digital design consultancy, offering 3D modeling, clash detection, quantity estimation, and project visualization services to construction firms. Another strong opportunity lies in sustainable construction solutions. Startups can focus on eco-friendly materials, green building consulting, rainwater harvesting systems, or energy-efficient building retrofits. Construction technology tech startups are rapidly growing. Civil engineers can develop platforms for project management, cost estimation, site monitoring using drones, or AI-based construction analytics. Structural health monitoring services are another high-potential area. Engineers can provide sensor installation, data analysis, and predictive maintenance solutions for bridges, buildings, and industrial structures. Affordable housing using 3D printing or modular construction is also an impactful startup idea, especially in developing regions. These solutions reduce cost, time, and environmental impact. Additionally, civil engineers can start training institutes or online education platforms focused on software skills, site practices, and competitive exam preparation. With technical expertise, field experience, and innovation, civil engineers can build startups that solve real-world problems while generating sustainable income and social impact. Applications of latest technologies in real-world projects. The true value of technological advancement in civil engineering is revealed when it is applied to real-world projects. Across the globe, modern technologies are improving infrastructure safety, efficiency, sustainability, and resilience. Advanced materials are strengthening bridges and buildings, smart planning tools are reshaping cities, and data-driven systems are helping engineers anticipate future challenges. These applications are not experimental concepts, they are actively transforming highways, metros, urban housing, and disaster-resilient structures. In this section, we explore how the latest civil engineering technologies are solving practical problems and building smarter, stronger, and more sustainable infrastructure for the future. Infrastructure resilience. Through advanced materials, infrastructure resilience is a top priority in modern civil engineering, especially in the face of climate change, natural disasters, and aging structures. Advanced construction materials are playing a crucial role in improving the durability and performance of real-world infrastructure projects. High-performance concrete, fiber-reinforced polymers, and self-healing materials are now widely used in bridges, tunnels, and high-rise buildings. These materials offer superior strength, corrosion resistance, and crack control, significantly extending the service life of structures. Self-healing concrete, for example, can automatically repair microcracks, reducing maintenance costs and preventing long-term damage. In seismic zones, advanced composite materials improve flexibility and energy absorption, allowing structures to withstand earthquakes more effectively. Coastal and flood-prone regions benefit from corrosion-resistant materials that protect infrastructure from harsh environmental conditions. By integrating advanced materials into design and construction, engineers are building infrastructure that is not only stronger, but also smarter and more adaptive. These innovations ensure that critical structures remain safe, functional, and reliable for decades, even under extreme conditions. Role in urban planning and smart cities. Modern civil engineering technologies are reshaping urban planning and accelerating the development of smart cities. Using data analytics, digital mapping, and intelligent systems, engineers can design cities that are more efficient, sustainable, and livable. Geographic Information Systems, or GIS, help planners analyze land use, traffic patterns, population density, and environmental factors. This enables better decisions regarding transportation networks, zoning, and infrastructure placement. Smart traffic management systems reduce congestion by adjusting signals in real time, improving mobility and reducing fuel consumption. Civil engineers also play a key role in integrating smart utilities such as intelligent water supply, waste management, and energy distribution systems. Sensors detect leaks, monitor usage, and optimize resource allocation, reducing waste and operational costs. Public infrastructure like roads, bridges, and public spaces are now designed with user experience and sustainability in mind. Pedestrian-friendly layouts, green corridors, and efficient public transport systems enhance urban quality of life. Through smart city initiatives, civil engineers are transforming urban spaces into connected ecosystems that respond intelligently to the needs of people and the environment. Future of civil engineering. Trends to watch. The future of civil engineering is shaped by rapid technological innovation and evolving global challenges. One major trend is the increasing use of artificial intelligence and data-driven design, allowing engineers to predict performance, optimize structures, and improve decision-making. Digital twins are emerging as powerful tools, enabling real-time monitoring and simulation of infrastructure throughout its life cycle. These virtual replicas improve maintenance, planning, and asset management. Automation and robotics will continue to expand, making construction faster, safer, and more efficient. From autonomous equipment to large-scale 3D printing, construction methods are becoming more advanced and cost-effective. Sustainability will remain a dominant trend, with greater emphasis on carbon-neutral construction, renewable energy integration, and circular economy principles. Climate-resilient infrastructure design will become essential worldwide. Finally, civil engineers will increasingly work alongside data scientists, urban planners, and environmental specialists. The profession is evolving into a multidisciplinary field that blends engineering expertise with technology, innovation, and sustainability, defining the future of global infrastructure. Conclusion: civil engineering is no longer limited to concrete, steel, and construction sites. It has evolved into a powerful combination of technology, sustainability, and innovation. From intelligent design tools and advanced materials to smart infrastructure and automation, today's civil engineers are shaping a future that is safer, smarter, and more resilient. These advancements are not distant ideas. They are actively transforming real-world projects, cities, and national infrastructure. Engineers now design structures that can monitor themselves, adapt to environmental challenges, and operate efficiently throughout their life cycle. At the same time, sustainability and climate resilience have become core responsibilities, ensuring that development meets both present and future needs. For students and professionals alike, this transformation opens exciting opportunities for growth, learning, and leadership. Civil engineers are becoming problem solvers on a global scale, addressing challenges such as urbanization, climate change, and infrastructure aging. As technology continues to evolve, the role of civil engineering will only become more significant. The future of infrastructure depends on engineers who are ready to innovate, adapt, and build responsibly. Civil engineering is not just constructing structures, it is constructing the future of humanity. If you found this video helpful, make sure to like, share, and subscribe to Civil Engineering Edge. Your support helps us create more high-quality content on modern civil engineering, emerging technologies, and career opportunities. Don't forget to hit the notification bell so you never miss an update. Let us know your thoughts and questions in the comments. We'd love to hear from you. Together, let's learn, innovate, and build smarter infrastructure for a better tomorrow. This is Civil Engineering Edge, where engineering knowledge meets the future.